Hey guys, decided to put together a video related to the CNC conversion components necessary to convert the X, Y, and Z axis. I've been getting quite a few emails over the last couple of months actually, but more here recently on all the necessary components to do this. I do have the majority of all the links up on my site, but they are kind of scattered around from page to page. Those that don't know, it's at www.quarter-scale-pro-street-beretta.com. I'm going to put together a CNC conversion price list / hardware page here pretty soon. I can get that up on my site. That'll make things a lot easier too. At the end of this video, I'm going to put together all the part numbers for just the hardware on my site. It'll be a little bit easier for people to actually follow probably. I just want to do it on the video here till I can give you all an idea about what I'm kind of talking about here. I do understand it is a bit difficult sometimes to understand. Newbies out there that don't know that much about the components, what's necessary to do it, whether you're mechanically inclined or not does play a big role too. We'll start up here with the Z-axis first. Obviously, you get your sides. These are identical as far as your machining. If you look close at it here, you'll see that there's this a 45, I think, degree angle it was. I'm not sure right offhand. On this side here, it's actually the same as the other side. It came down like this. You have to notch this out to have significant gib screw clearance when your ram goes all the way back up, so that it will have clearance. So you have adjustment to your gib screws should this be all the way up if you need to. If you don't, it will stop. Obviously, it would stop right in this area here. And that would eliminate probably about 4 or 5 inches of travel, upward travel. So notch that out, and then it'll eliminate that problem. You have your base mount. You don't have to notch the front sides of it. That's really not necessary. I did, just to eliminate the points from the corners. You're reaching up, you might hit your hand on it. Would be no different than hitting your hand on a corner like this corner here. They are pretty sharp. You got your slider bracket here for your steppers. Standoffs will mount to. Half-inch hex. 3/8. 3/8. Half-inch. You got your thrush bearing, which is this part here. Recesses down into the mount itself. Below it you have a thrush needle bearing that sits up in here. There is also a thrush needle cage flat washer that sits up in here. Requires 1, maybe 2. The washer just kind of serves as taking up any gaps that you might have in between there. If you machine them correctly, you can pretty much eliminate the washer entirely. I do have one in it. I'm going to put on the list people that's going to do this type of conversion to get 2 of them. Just better be safe than sorry. got the bearings from MSD Industrial Supply, and that'll be all at the end of this video. I got my pulleys from SD PSI, which I'm sure all is very familiar with. Roton ball screws, roton ball nuts. Then you got your block down here. On the back side of this block, there's, I believe it was a 1/4-20 hole. It's recessed. The end of your ball screw is tapped. Yeah, the mount here for that is recessed, countersunk. Same thing. And that secures your ball screw. Then you got your bolt holes here and over here. That bolts to the head. Keeps it in line with the rest of the assembly there. That pretty much sums up the Z-axis. I don't think it's all that necessary to go into the steppers and stuff like that. They got the pulleys and everything. The belts from SDPSI. Down to the Y-axis. This one is a little bit tricky to do too. Nowhere near as complicated as Z, however. Got a block here. It's kind of hard to see right now because everything I got in here. You got a block here. It has a recessed bearing, a thrush needle bearing, two of them, one on the back side, one on the front side. Then you have, I believe you can see them here, two jam nuts that secure them bearings. The back side bearing, the actual base prevents the bearing from going any further backwards. It stops that. You will need to tap two additional holes in the base to secure it. The stock one is a 1/4-28, I believe. I retapped both of them to 1/4-20. Additionally, down at the bottom hole, you have to completely drill and tap that at a 1/4-22. Them are recessed into this block here. This block here that mounts to that, you can see that there's just two screws that hold that. One here and one over here. Three screws rather. There's one down below that too. It's a little difficult to see. The 4 standoff screws, these are 1/4-20s as well. They mount from the back side. Don't know if you can see this or not. They're countersunked as well, all 4 of them. These you don't really have to countersink. With a 1/4-20, if you countersink them any further, you're kind of not going to have a lot of meat there on the side for that to adhere to us, if you want to say it that way, I suppose. It eliminated quite a bit of strength. That's 3/8. You could go with a 1/2 inch. Bring this out just a little bit further, and then completely recess that head in there. It's not necessary to do it at all, really. It won't really interfere with nothing. That's pretty much it on the Y-axis. The Z-axis is by far the easiest. It uses the stock X2 bearings. There's nothing to change out. Whether you're running with the original Acme lead screws, or with the ball screws, as I have. You just simply set it all up in there. Put your original washers back on it. And just 2 jam nuts. Same jam nuts set up as it's on the y-axis. It's just hard to see, but it's just identically set up like this one. There's just 2 of them there. As you can see, there's just 3 screws that bolt it to the end of the table. You'll have to drill and tap all 3 of them. Them are 1/4 20. Locate your center. Bore that out. Preferably on a rotary table. Whichever way is most convenient for you, I suppose. You could use a hole saw a few different ways. I did mine on the rotary table. Homemade rotary table at that. Same applies here. This is 3/8. 1/4 20 screws on the back side. Countersunk, so they'll clear the table. All 4 of them. Bottom 2 is not necessary to countersink if you prefer not to, because there's nothing to get in the way from that, so them could actually stick out further, but I prefer to countersink them myself. And as you can see, since that one video I put together too, I have redone my standoffs now. I got these all done correct. Remember before in that one video, if you had looked at it, I had a 1/2 inch nut, approximately a 1/2 inch nut or so in here, and I had spacers behind here as well to bring that out further. It's done the correct way now, and that's how it's going to stay. All stepper motors are from Keeling. 381 ounce holding torque. At the end of this video, I'll put a screen together on all the parts, the hardware that's required. And as I mentioned, I'm going to get on my site here eventually, and I'll put together, I'll put together a complete list of all the hardware, all the necessary materials from A to Z. It'd be a lot easier for people to follow that way then too, that do want to convert the mill as I have. So check out my site, I suppose, guys. Thanks for taking the time to watch the video.